Welcome to our video lesson on evaluating and modeling algebraic expressions. Yesterday you learned what a variable is, and you noticed that all of these expressions here have variables in them. They're called expressions because they don't have an equal sign. If they had an equal sign, like this, then it would be an equation. But these are called expressions. We can model, so represent algebraic expressions with something called algebra tiles. Algebra tiles are these, the little squares and rectangles to represent different things. When we model this expression, 5x plus 3, using algebra tiles, we model it using these green rectangles. These ones represent the x's. There are 5 x's, so we put 5 green boxes, 1, 2, 3, 4, 5. Then it says plus 3. Now notice that the 5x has the variable in it, but the 3, actually I'm going to do this in green so it makes more sense. 5x has the variable, but the 3 doesn't have a variable. It's just by itself. That means that they're actually different things. You can't combine these because the first one is 5x and the second one is 3. So we can't add them together. We have to leave them as separate things. And that's what the algebra tiles show you. There's 5 x's and then we have plus 3. So we have 3 ones down here. The next expression, it says x plus 2. So we have 1x and then we have 2. We are going to represent that x using a green rectangle. So on your note, you're going to draw a green rectangle like this. Now I know mine's not a perfect rectangle, but that's the best I could do with the tools I'm given here. Oh wait. Yep, that's it. So I have 1x and then it says plus 2. Now because the 1 has a variable, x, and we have plus 2 as something else without an x, that means that the 2 are going to be represented using yellow squares. So I need 2 yellow squares to represent my plus 2. There we go, that looks better. So now we have 1x plus the 2 little yellow ones that represent the 2. The last one down here, we have 4x plus 8. 4x plus 8 means we have 4 x's. Just like here we had 5 and over here we had 1. Even though this doesn't say 1, there's a secret one out front that we don't need to write because if there's only 1 x, we assume there's just one of them. So here we have 4 x's. So I need to put 4 green rectangles to represent my 4 x's. So now I have my 4 green rectangles to represent my 4 x's. Now I still have this 8. And that means 8 ones. So then I'm going to put 8 little yellow little yellow squares to represent my 8 ones. So now we have 4x plus 8 represented using our algebra tiles because we have 4 green rectangles to represent the 4 x's, and then we have the 8 little yellow squares to represent the plus 8. Okay, so now we've talked about how to show the expressions using algebra tiles. So the next thing we're going to do is something called evaluating. Now if you hear the word evaluate, maybe you think of a test or a quiz where a teacher's evaluating your knowledge, an evaluation. Well, that's just trying to see how much you know or the amount that you know. For expressions, when it says evaluate, we need to figure out what they're equal to. So it says evaluate 2 times x minus 8 for x equals 11. Now this x equals 11 part is really important. That tells us what x should be in this expression. So what we're going to do is instead of writing that x, we're going to write 11. Now we can't just write 2 and then 11 because that looks like 211. Remember that this is sneaky and it actually means 2 times x. So that means we have 2 times, I'm trying to make my dot, 11 minus 8. Why 11? 11 because it told me right here that x is equal to 11. Then I use PEMDAS in my order of operations to simplify this. First, I'm going to multiply because multiplication comes first. So 2 times 11 is 22 minus 8. Then 22 minus 8 will give me 14. And I'm done. When it says evaluate, you're going to substitute, just like a substitute teacher gets put in the place of a normal teacher, you're substituting in the value of x for your x. A few things to watch out for. The first thing, notice that I wrote equal signs right here. They're all lined up and I've shown all the steps. You need to do the exact same thing. You need to make sure that everything's written in a line and that you write an equal sign at the beginning of each line. Let's do some more examples. Number 2, it says evaluate each expression for x equals 8. So we're going to substitute, or like a substitute teacher, instead of writing this x, we're going to write an 8. Now I'm going to do this first one. We have 3 times x plus 15. I'm going to write my equal sign. Make sure you write your equal sign. And then I'm going to write 3, and you can't write 3 and then just 8, because that looks like 38. You have to write 3 times 8 plus 15. Now we use our PEMDAS. Multiplication comes first, so 3 times 8 is 24 plus 15. Now we're going to add 24 and 15, and that gives us 39. So we're finished our first one. Again, notice I put equal signs all lined up in a line down the side. I expect yours to be written the exact same way. Okay, let's do B together. We have 5x divided by 10. So I'm going to write an equal sign, and then 5. Now I can't just write 5, 8. I have to write 5 times 8 divided by 10. In PEMDAS, when we have both multiplication and division, we go from left to right. So we'll start with 5 times 8. That gives me 40 divided by 10. Now 40 divided by 10 is 4. Okay. Then it says evaluate each expression for y equals 7. Instead of the variable that they chose in this one, instead of being an x, it's a y. And if you notice, there's y's in all of these. That's completely fine. Just instead of putting an x, we put a y. No problem. And so this one here is 56 minus 4y. That would be equal to 56 minus 4 times y. Make sure this time symbol is bigger so you can see it. There you go. 4 times y. Oh, sorry. I did that wrong. Instead of writing our y, we need to write our 7. So I'm going to erase the y, and we're going to write a 7. Now, using PEMDAS, the first thing we're going to do is multiply. So this will be 56 minus 4 times 7, which is 28. So then we need to do 56 minus 28 to get our answer. 6 minus 8 we can't do, so we borrow from the 5. It becomes a 4, and we have 16 minus 8, which is 8. 4 minus 2 is 2, so we get 28. This next one looks more complicated, but I'm sure we can do it. So instead of writing our y in this line, we're going to write our 7, but everything else is exactly the same. So parentheses, 7. Then I need to put my times symbol so it doesn't look like 77. Times 7 minus 9 divided by 2 squared, or 2 to the power of 2. The first step in PEMDAS is parentheses. So I'm going to solve what's in the parentheses first. Inside the parentheses, I have both multiplication and subtraction. Well, multiplication comes first, so I'm going to multiply first. 7 times 7 is 49. I still have parentheses, so I'm going to keep going with that. 49 minus 9 is 40. Now that we just have one number left, I'm going to leave it. We'll write divided by 2 squared. The next letter in PEMDAS is E for exponents. So the next one we're going to do is our exponent. Now 2 to the power of 2 means 2 times 2, and I know that's 4. So this would be 40 divided by 4. And 40 divided by 4 is 10. So that one looked really big and scary, but we were able to do it without a problem. Okay, you're also going to have these type of problems where it says complete the table. At first it looks like a lot, but don't worry, it's actually very straightforward. What it's saying is this is our expression here, x plus 7. And our different values of x are over here. So for the first one, it would be x equals 2. If x is equal to 2, this expression would be 2 plus 7. Well, 2 plus 7 is 9. Okay, that's what we would write in our table, the 9. The next one is 5, so let's pretend x was equal to 5. If x was equal to 5, we would have 5 plus 7, and 5 plus 7 gives us 12. So in our table, we'd write the 12. The next one, we have an 8 now. So we're saying if x was equal to 8, what would this expression give us? So it would be 8 plus 7, which is equal to 15. Next one, 11 plus 7. 11 plus 7 is equal to 18. And that's what we have to do for the table. We substitute in if x was equal to each of the values in our table. Okay, over here we have x, 3, 6, 9, and 12, and over here we have 5x. Now remember, this means 5 times x. So if x was 3, we'd have 5 times 3, which is equal to 15. Now let's say x was 6. We'd have 5 times 6, which is equal to 30. The next one, if x was 9, we'd have 5 times 9, which is 45. The last one, 5 times 12, is equal to 60. Now some of you might be noticing the pattern along the side, which is great. If you notice the pattern, that's really good, but always be careful that if you're looking for a pattern in one column, there's a pattern in the other column as well. Here we're going up by 3's each time. So our pattern's the same on the other side too. We're going up by 15s. For now, don't use the patterns to help you use the math. Actually complete the expressions later on. You can use the pattern. So what you need to do right now is this practice. So you're going to complete all of the ones that are highlighted in yellow. Make sure you show all of your work, line up your equal signs, and work very, very carefully. I'm going to be checking it, and if you do not show your work properly with each step with the equal signs, you will not get the full credit for it. So right now, get started in your notebook with the practice. Try your best. I hope the lesson went well. If you have any questions, as always, please let me know. That's all for now. I'll talk to you later.